Here we go, guys, the home stretch. We've got probability and then we're done. I know, it's so exciting. Great job on your transformations. Those of you that have completed and submitted the quiz, you did a pretty good job. Those of you that haven't finished or submitted the quiz, please do that. Okay, don't forget that I'm waiting for those assignments. So we're gonna jump right into probability here and talk about what it actually means and where we're going with this. You guys know what an experiment is, right? It is an investigation. Oops, you know what? I'm going to use blue. With varying results. Right? So we're going to do something and there's things that could happen. That's pretty much what we're doing. Okay. An outcome is, an example of one of those investigations might be like flipping a coin. Oopsies. Okay, we've all done that. Flip a coin, right? You get two outcomes, right? So your outcome would be the result from an experiment. So if you were to flip a coin, what would one of those results possibly be? Heads. What could another result be? Tails. Okay, so there's a couple different things that could happen. I'm not sure why that black line is there, but we're just going to leave it for now. Okay, so there we go. That's what we have there. We've got an investigation, or an outcome is what could happen. Okay, a sample space is the set. Oops, still. Of all possible outcomes. So in this case, we would do fancy brackets, heads, comma, tails. Fancy brackets. So that would be our sample space. All the things that could happen, right? You can't get anything different than heads or tails. Okay, so let's try some examples. A state that begins with the letter O is chosen. Okay, so our sample space here would be Ohio, Oklahoma, and Oregon. So we only have 3 possible outcomes, right? What about a day of the week is chosen? Okay, so our sample space would be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So we have 7 possible outcomes. Okay, pretty straightforward. Okay, so now that we have that kind of backgroundy stuff figured out, let's talk more about probability. A probability is a measure of the chance of a specific event occurring. Okay, so what we're going to be using here is the capital P, that stands for probability, and then what's inside is the event occurring. Okay, so if we go back up to our example of heads and tails, the probability, and then in parentheses it would say heads, then you would say, okay, well there's a 1 in 2 chance of getting heads when you're flipping a coin. If it was asking for the probability of getting tails, you would say, okay, P, and then in parentheses it would say tails. You'll see it more as we go through and it'll make more sense. Okay, so expressed is the probability is expressed as a ratio of favorable outcomes to the total number of outcomes. The ratio can be written as a fraction, decimal, or a percent. Okay, we are going to stick to fractions. Okay, so anywhere you see where it says do this as a fraction, decimal, and a percent, guys, just do fraction. Okay, we're just going to stick to fractions. We're going to leave it like that. I don't want you guys spending all that time. I mean, not that it would be a lot of time, but it'd take up some time putting them into a decimal and a percent. So we're just going to focus on fractions today. Okay, so let's go ahead and do some examples, and I think it'll really start to click for you. All right, so we have a spinner here. And not that I can say I appreciate distance learning for, well, any reason, but this is helpful because usually when I make you guys worksheets, they're not color-coded or you can't see it because the shading is weird. So this is probably the only time I'm like, yes, you guys can see the example clearly, right? There's no question about this spinner and what is shaded and what's not shaded. So this is great. Okay, so it says given each probability as a fraction, in simplest form, a decimal and a percent. So let's go ahead and cross out where it says decimal and percent. Oops. Cross out where it says a decimal and a percent. We don't need to do those. Okay, so on your practice page, if it says as a decimal and a percent, don't do that. All right, I don't want you to do the decimals and percents, just the fractions. All right, so what's the probability of getting a 9? That's what this first one is saying, letter A. So if I look here at letter A, I would say that, what's the probability of spinning a 9? So my answer would be 1 out of 16 because there's only one 9 on that spinner and there are 16 possible numbers it can land on. Okay, so how about the probability of at least a 12? So I'm looking for any number that is 12 or greater. Well, if I count those up, I get 12, 13, 14, 15, 16. So there are 5 numbers greater, or at least 12 out of the 16 total. All right, a perfect square. Okay, so what are the perfect squares that we have here? Well, we have 4, we have 9, and we have 16, and we also have 1. I guess 1 counts as a perfect square. So we would say there are 4 out of 16 perfect squares there, and we're going to simplify that to 1/4 because it does say in simplest form, right? We can't ignore that part. Okay, how about probability of a not shaded number? So how many of those numbers on here, how many of these spaces are not shaded? So we end up with 7 out of 16. A 2 or an 11, well, that's going to be 2 out of 16, which will simplify to 1/8 because there's only a single 2 and there's a single 11, so that's 2 total possibilities out of the 16. And then a multiple of 5, well, we got 5, 10, and 15, so that's going to be a probability of 3/16. Right? So we're just looking at what they give us and we're counting up. Remember, we're just counting how many things qualify out of the total possibilities, right? So if I go back through here, I would say 1 thing qualifies out of 16 possibilities. 5 things are at least 12 out of 16 possibilities, right? Okay, let's scoot on over to the next page. Here we go. We're just going to keep doing some more examples so you guys get the hang of this and you can do your practice. All right, so we have example 4. A month of the year is chosen at random. Find each probability. Okay, so this is assuming you guys know your months of the year. This is when I would give you guys the whole, if you don't know this, we have bigger problems look. So imagine I'm giving you that, and let's go ahead and find these. So how many months start with the letter J? So January, February, March, April, May, June, July. So there's 3. And how many total months are there? 12, but we're going to simplify that to 1/4. That would be our final answer. How about how many months start with the letter T? Hopefully you're thinking, Mrs. Marsh, there are none. And you're right. So you would get 0 out of 12, which simplifies to 0. The probability is 0. It's not going to happen if you try to find a month that starts with the letter T. How many months have at most 30 days? So how many months are there that do not go over 30 days? Well, there are 5 out of the 12. I'll just give you that one. That one's kind of hard. I can never remember. I have to look at a calendar every time. All right, question 5. A letter from the word probability is chosen at random. Find each probability. So what are the chances? What's the probability that you would pull the letter B? Well, we have 2 B's in the word probability, and there are 11 letters. So that's going to be 2 11ths. How about a vowel? How many vowels do we have? 1, 2, 3. Oh, there's 4 vowels out of 11 letters. How about the letter Y? 1 out of 11, right? All right, now we've got a pencil box here that contains 5 red, 6 yellow, 8 blue, 3 orange, and 2 purple colored pencils. If one is chosen at random, find each probability. Well, the first thing I'm going to do here is I'm going to figure out how many total colored pencils do I have. So 5 plus 6 is 11, plus 8 is 19, plus 3 is 22, plus 2 is 24. So our total is 24. So that's going to be the denominator for all of our probabilities, unless, of course, we simplify it. All right, so what's the probability of pulling a yellow color pencil? Well, there are 6 yellow out of 24 total, so then we would simplify that to 1/4. How about blue or purple? So I have 8 blue and 2 purple, so that's going to be 10 out of 24, which is going to simplify to 5/12. Okay, how many are not orange? Ooh, this one always gets people. So what I need to do is add up well, I know that there are 3 orange, so I'm just going to take 3 away from 24, and I'm going to say, well, 21 of those are not going to be orange. And then, believe it or not, you can simplify this because 3 goes into both of those, so this would be 7/8. Okay, so hopefully you guys are kind of seeing where I'm going with this. It's a lot of counting, okay? All right, let's finish up our examples here. If a card is chosen at random from a standard deck of cards, find each probability. Okay, this one is a little bit trickier because if you don't know deck of cards, this might not be easy for you. But I'll just tell you that there are 4 queens and there are 52 total cards, right? So we can simplify that to 1/13. Okay, again, if you don't know cards, that's kind of hard. So just do the best you can when it comes to any kind of probability that asks for decks of cards. If you don't know it, just skip it, right? I don't want anybody going out and teaching themselves all the ins and outs of a standard deck of cards. Okay, and when it says standard deck, it's talking about, you know, ace through king of hearts, ace through king of diamonds, clubs, and spades. Okay, so probability of getting a red 3. Well, there's going to be a 3 of hearts and a 3 of diamonds. So you've got 2 chances out of 52, which would then simplify to 1/26, okay? Because there are 52 cards in an entire deck. And then the probability of getting a spade, well, there's going to be 13 spade cards out of 52 total, so that's going to be 1/4. Okay? So hopefully you're seeing this isn't so bad. All right, let's briefly talk about the complement of an event. The complement of an event is the probability of the event not occurring. Since the sum of all probabilities in a sample space is 1, the probability of an event not occurring is the probability of the opposite, right? So we would say it's 1 minus whatever our probability was, okay? So let's go back up here. So well, we'll jump into the examples down here. It'll make sense once you see it. Okay, if the probability that it will rain tomorrow is 3/8, what is the probability it will not rain? So what's left over from the 3/8? Well, we have 5/8 left over, right? Because if we take, based on the example they gave us, 1 minus 3/8 is going to be 5/8, because that's like saying 8/8 minus 3/8 equals 5/8. Okay, so we're finding basically what's left over. So if the probability that someone will win a game at the carnival is 1/24, what is the probability they will not win? So if I take 1 minus 1/24, I'm going to get 23/24 chance that you will not win. That's why it's really hard to win those super big stuffed animals, guys. Okay, they make those games so it's very difficult to win, just saying. All right, number 10, a number from 1 to 20 is chosen at random. What is the probability that it is not prime? Oh my gosh. So let's refresh our memories. What is a prime number? It's a number that only has 2 factors, 1 in itself. So let's write out all of our prime numbers between 1 and 20. Remember, the number 1 is not considered prime. It's a special number, special situations. So we have 2, 3, 5, 7, 11, 13, 17, and 19. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8/20 are prime. So 1 minus 8/20 is going to give me 12/20 that are not prime, which simplifies to 3/5. Okay? Right? Because I'm subtracting 8/20 from 1, which is like saying 20/20 minus 8/20 gives me 12/20. Okay, last example, and then you get to work on your practice. If a state is chosen at random, what is the probability that it does not begin with the letter M? All right, I'm just going to tell you that there are 8 out of the 50 states that do start with the letter M. So if I was going to subtract that from 1, I'm going to end up with 42 states out of 50 that don't start with the letter M, which can be simplified to 21 out of 25. Excuse me. Okay, as our final answer. So again, you're just trying to find, after you know what is possible, what's not possible. Okay, so that's your practice. Or excuse me, this is our notes. Now you can go open up the practice file. Please make sure to submit it. I know a lot of you are doing the work and then you forget to submit your work. So please do that. And hopefully you're not scared away yet from probability. I think you'll find that it's pretty interesting stuff. All right, talk to you guys soon. Thank you.